Alrighty, everyone, we're going to go ahead and get started. So first off, thank you everyone for joining our webinar today. We're excited to show you how you can leverage AI to transform your cement production process. So this is our IEEE PCA digital workshop. It's essentially our best digital alternative to the conference this year that we all wish that we could have met you at in Vegas, but under the current circumstances, I'm glad we were still able to connect with you some way. And also I'm hoping that everyone's staying healthy and safe out there. So today, this is our agenda. We're going to take about 40 minutes to get through the entire session. And so first, we're going to start with a very brief introduction to who is Petuum and what is our approach to artificial intelligence. Then we're going to get into the fun stuff. So we're going to get into the machine learning applications for cement and concrete. So during this portion, we have a broad range of different applications, clearly that machine learning can be applied. We're going to focus on one certain segment of the actual manufacturing process today. And during that section, we're going to be talking about example configurations. We're going to talk about example use cases and results, and even some projected savings. And then lastly, as part of the conference this year, we did have a paper submitted and accepted. So unfortunately, we're not going to be able to speak there, but this was our next best alternative. And then that project that was written about during this paper by Dr. Roberto Linares, that will be touched on throughout today's session. And then also at the end of the webinar, we'll make sure to get you a copy of that as well if you want to read through it. And so clearly I'm joined today by my peers, Unity and Roberto. Would you folks mind giving just a 30-second introduction to who you are for the audience? Unity, we cannot hear you.
Thank you, everyone. Thank you, Christina. Thanks for joining. So my name is Unity Kingi. I am head of customer solutions at Petuum. And today we will be talking, as Christina was mentioning, about some of our product solutions and use cases around cement and concrete. Just to introduce myself, I've been with Petuum for more than a year now. And before Petuum, I was working for a company called Caterpillar. I've been, I have experience in several industries working around product development, specifically for AI solutions. And my last role with Caterpillar, I was heading the AI solutions for the energy and construction sectors. Again, thank you for joining.
Yes, I am Roberto Linares. I am AI Solutions Principal. I have worked in the cement industry for a few years. Then I have worked also with process data historians, real-time information systems, application development, and I have been collaborating with implementation of Optimum, our product for optimization in the cement industry.
Great, thanks guys. All right, I'm going to go ahead and kick it off here. Again, I'll keep this part light and brief so we can get to the specific applications for cement. So first off, we are a startup. We were founded a couple of years back. Our co-founders, they actually came out of Carnegie Mellon University, CMU, which is a leading school for artificial intelligence. And our chief scientist actually is still the head of research at the university. And so what you can see over on the right is we have continued to carry on that legacy, the importance of doing R&D, continuing to evolve some of the latest and greatest cutting edge technologies in the AI space. And for that, we've been recognized by some of these awards. We're continuing to grow upon that. In fact, last year we were recognized at the International Cement Conference over in Berlin for the Cement Project of the Year. And so that was the first award that we received from industry. It was a really proud moment for us to kind of step outside of just technology and actually be recognized for some of the work we were doing in the field. And then the other thing I want to say is that while our roots are definitely founded more in academia, our founders, they very quickly started to realize that whenever they were trying to provide solutions for enterprises, for large organizations that had real world problems, things with dirty data, inconsistencies, they may or may not have had the staff on board, like the data scientists, the machine learning engineers, the talent. It became very difficult to make AI scalable and accessible for some other organizations. So really that's why they went about founding Petuum as a company. So being able to provide fast time to value, reliable and scalable solutions that could be launched at any organization. And so this next slide here shows a little bit about how we are providing those solutions to industry. And you can see on the top, we go well beyond cement. So we offer solutions in like the steel markets, logistic, chemicals, oil and gas. We even have customers in some other spaces like healthcare, for example. But the foundation here that everything is built on top of for us is our Orchestra platform. And so if you look at this almost like a 3-layer cake or 3 different stacks, these are all different options for ways that Petuum can be consumed by somebody. And so on the bottom layer, this is our proprietary platform that ingests data. It does the data preparation. This is the scalable piece that allows us to tap into different data sources. So different data historians, even other third-party applications where different data may be stored, being able to collect all of that together, do the model training and the serving in using distributed learning techniques, which basically means we don't need as much data and we are able to provide fast and timely results, as well as after you have a solution, how do you make sure that you're able to scale that from line to line, plant to plant, and continue to maintain it over time. And so that's all included as part of the platform here. The next layer is what we call our AI accelerators, which are basically different, we also like to call them building blocks. So different core techniques and elements of building an AI solution, which can be strung together in order to solve a problem. And so here are just a couple of examples for you. And then the top layer is how do we actually string these building blocks together to solve a standardized problem. So within the cement realm, we'll be talking about a few of those today. And these are basically the end-to-end solutions. So for the folks who have an idea, they may or may not have the staff in-house today who are ready to build it. That's where the industry solutions would come in. The next layer for the accelerators are someone who has a digital transformation strategy. They have some staff and a team on board to do that, but maybe they don't have the right specialists. And so you could basically augment that team by implementing some of our accelerators. And then lastly, if you do have a data science team, if you're ready to rock and roll, but you just need that platform to integrate all of your data sources, this is where the platform would come in for AI at scale. And so just while we're getting started here, I do have a couple of polling questions to ask you folks throughout. And so we're going to test one out right now. All right. And I'm launching this. You guys should all be able to vote. So the question is, out of these 3 different layers, I'm curious, what is the most difficult challenge for your organization whenever you're considering adopting AI? Is it the AI at scale component? I know there's a lot of different global organizations, sometimes 10, 20, 30 lines or more. Is it the lack of talent? Or is it bringing your ideas to production? Actually being able to see value, seeing it on a actually providing some ROI. Looks like we still got a couple people submitting their votes, so I'll give you a few more seconds. Great. Alrighty, so it looks like our winner is AI at scale. So the platform approach, and then we have a tie actually between the AI talent and ideas to production. So great, you'll see a few more of those throughout the presentation, but okay. So this next slide here, I wanted to basically be able to help you visualize how we're actually bringing these solutions to light. I know that AI is talked about hypothetically a lot, but this is actually how we are doing it. So what you're seeing here is the user interface for the orchestra platform. And so here are some of like the options for those accelerators, those building blocks that we referenced, as well as the actual tuning the parameters and training these models. This is what your data scientists or potentially even your software engineers would be using to create these models. And then on the top, these are those building blocks. And you can see that we've strung a couple of them together to create a solution. And so this one was a fairly basic solution. I just wanted to give you guys an idea of what the accelerators would look like. And then ultimately, whenever we're creating the industry solutions, which Unity and Roberto will hit on in a second, how we actually put those together. So you're not starting from scratch every time, right? We actually have these building blocks already made, and we're just configuring it based on what your needs would be as an organization. Great. And so I told you I'd keep it brief. This next part of the conversation is about how do we actually apply these core ML techniques to the cement industry. And so in-house here at Petuum, we've got some different AI specialists. So there's a number of specialty areas under the larger AI umbrella, whether it be computer vision, NLP, or complex decisions like dynamic systems and time series. So today we're going to be focusing mostly on computer vision and complex decisions. If you guys do have an interest in any other areas of AI, feel free to contact us afterwards and we'd be happy to have a conversation there as well. So with that being said, Unity, I will hand it over to you.
Thank you, Christina. So as Christina mentioned, we will be deep diving into the cement and the concrete space today. As you all know, the cement and the concrete value chain, it comprises all the way starting from planning, procuring, and then making the product itself, which is the cement, delivering, and then finally managing on a day-to-day basis. So Petuum is working on several use cases that actually span various of these areas within the value chain. But today what we're going to do is we're actually going to focus and deep dive into the make area, which is the core cement operations, which actually is making the cement product, and how do we optimize that operations. And we want to give you 3 examples of the offerings that we have. And also this represents really the different AI technologies that enable bringing value to the core operations of the cement make. So we'll talk about soft sensors, which are, again, we'll deep dive into in the next slide, but this is a prediction solution. And then asset and process optimization. This is real-time optimization of your assets and process for cement manufacturing. And then this is a optimization solution. And then thermography analysis, which is a computer vision solution. And we'll kind of talk, what value does it provide for each one of these. So talking about the soft sensor. So what is soft sensor, right? So basically, soft sensor is a virtual or a data-driven sensor. What this allows you to do is that when actually measuring a process variable becomes very difficult, either because it is complex, either because there is a sensor available for it, or because you need to have a manual data collection, too expensive or cumbersome, or you are actually measuring something, but it's more manual and at a low data frequency. Maybe you're measuring some lab samples for, say, every hour or every 2 hours. Soft sensor enables, taking in the process variables, inputs that are key, that will help predict an output, which would be the soft sensor which is the virtual sensor, taking multiple variables into account and then predicting more frequently. And that frequent prediction helps drive insight, which help improve the process further. So for example, I'll probably talk on one of the application in more detail. So the applications that we are looking into are the kiln-free line soft sensor, cement fineness, which is the ball mill, like fineness predictor, or loss of ignition. These are the applications. So let me talk about one of those a little bit more detail. So for cement fineness prediction, what we do is we take multiple inputs from, say, a ball mill, which the goal of the ball mill is to grind the product into fine powder. And so we take multiple inputs, whether it is like separator power, the main drive power, mill fill, temperatures, etc., and then predict the blane or the PSD in a more frequent predictions, which help finally, once you have that prediction, you are able to effectively manage the ball mill, say, separator speed in a manner that you would traditionally not be able to. So Petuum uses deep learning methodologies to predict this over high frequency.
Yes, and this can be very useful for the cement optimization, cement and ball mill optimization at both sides. It could be the finish mill, or it could be the raw mill grinding. So initially, it could be a good indicator for decision making for the operator, in which we have, let's say, a hybrid of you do AI optimization for throughput of the mill, and then still you have it in manual for separator speed. Or once you're comfortable, you can include the optimization and control of the blade itself.
Great. So next we will talk about Petuum Optimum. So Petuum Optimum is our product for asset and process optimization. So Optimum has several modes of operation, and an Optimum is actually our cutting edge solution, which looks into several process variables for an asset or a process. And what it solves for is it solves for real-time optimization of that asset or process. I'll talk about the different modes of operations here, as well as kind of what is the value that each of the mode brings. So the first is correlation. So correlation is key as we are building the machine learning models. What we do is we take in the historical data that comes from that particular asset or process, and then based on the neural network modeling as well as machine learning techniques, we then basically understand how are the key process variables correlated with each other. And these relationships are key for the next phases, which is the predictions and the prescriptions. So that's the first one. The second one is prediction, which is the core for optimization. So prediction is where you are able to predict not just using the historical data, but also on live stream data, providing accurate predictions for the next 1 minute, 5 minutes, 15 minutes, whatever the asset or the process needs. So you're able to predict the objectives, the goals of that particular use case. And then prescriptions are making recommendations. So taking into account how the process or the asset is actually going to behave in the next 5-10 minutes, then the model looks into the best, within the search space, identifies what's the best fit optimization that the asset can go to, which will optimize whether that is energy recovery, whether that is improving the stability, whatever the goals of the asset are. It tries to then provide recommendations on a real-time basis, which optimizes for the operation. And then finally, a supervised tier, which takes these prescriptions, which can be either just monitored or actually supervised steer is where it is going back to the control system in a closed loop fashion where you are where the system is in the steer mode, where you are able to autonomously control the asset with the most optimized operation. We have this offering for different areas that you can see there: Pyro process, mills, alternate fuel for maximizing the substitution, primary emission, and the ML models, use both the prediction and the optimization framework for all of these.
Great. And Unity, I do actually have one live question for you from the audience. This actually goes back to the soft sensors on the previous slide, but do we have a soft sensor for the cement fineness of a vertical mill?
Yeah, so soft sensor is basically while you are measuring the fineness for the output, right? So soft sensor would be applied to both the mills, whether it is a ball mill or the vertical mill. Yes.
Yes, and probably in the vertical you will see more spikes because it's a more mechanical system and it has less residence time. But at the end of the day, if we capture the dynamics fast with with all of the data that we need, I mean we can apply the same concept.
Great, thank you.
So this slide is talking about what is the architecture? How would we connect with the customer's network, and how would the products, predictions and the optimization, real-time optimization, feed into the customer's data systems? So basically, what we have is we have a Petuum Edge data collector, which can be connected to either the control system OPC server directly, or it can be connected to a plant historian or the PLC. So basically could be connected to whatever stream of connection that is applicable to that customer. And typically what we have seen is that we connect to either the OPC or the plant server historian. And then that edge data collector is bidirectionally connected with our Petuum Orchestra platform through a secure MQTT industry standard data pipeline, sends the data to Orchestra. And then we internally have our framework where we are able to then we do the predictions, prescriptions, and provide the recommendations on a regular frequency that is determined for that asset back through the same pipeline to either OPC, plant historian, or PLC. And so that's kind of the end, a full close end-to-end working of how we would be able to connect to your systems to be able to provide value for the assets and the processes. Yeah, so with that, actually, I would like to give you a small demo of the operational dashboard of one example. So Christina, if you don't mind, I would like to share my screen.
No problem.
Thank you. Okay, so here's a demo of how the operational dashboard for Petuum Optimum would look like. So essentially what our operational dashboard does, it gives you a real-time view of how the asset is running with Optimum. So what we have is you will be able to see various aspects of the product and the various recommendations of the product. So the first one is what you can see is the product availability itself, meaning is Petuum Optimum actually in the auto steer mode or not. So, whenever the operator engages the Petuum Optimum product, you would be able to track over a period of time if the autopilot was on or not. It also helps you understand, because Petuum Optimum also has disengagements to make sure that the asset is running in the most safe zone. um, it can be disengaged for the reasons that it is going out of bounds, which are defined again with customer. So you would be able to look into those disengagements and what were the causes of those disengagements, which variable actually caused it. And over a period of time, those could be tracked as well. And then you can also view, if we are able to send you the signal and if there are any latencies with the product. So that also can be monitored, which is around really products availability. And then it comes to the more interesting part, which is, for every use case, we typically define like, what are the objectives, what are the goals? So for this demo, we have a cooler example in the cement. So this is a great cooler. And what you can see here are the trends over a period of time for, say, secondary air temperature. So, so the goal is to maximize the secondary air temperature, minimize the clinker temperature, for example. And so what you will be able to see is that, what is the real-time value? So what is the real-time operation of it? Well, and then the forecast, meaning we are predicting what the real time is going to be. And then finally, if you were to use the prescriptions of Optimum, where would the secondary air temperature land at? So for this entire operation over a period of time, you can just see that, the real time was 1600, for example. And if you were to use Optimum, this would give you a benefit of increase in secondary air. So that is these are the panels which explain you about the objectives of what you are trying to achieve with that asset. And then prescriptions. So the prescriptions are the recommendations that AI is providing, the best set point or the most optimal set point for the asset to take. And so you can see here, we give you a view of all the prescriptions and how you can also be monitoring, how much percentage of time each prescription was actually engaged. So there is an option to even pick which prescriptions you actually want to accept. And so this gives the functionality of that as well. So just wanted to give everyone a view of how the operational dashboard looks like, what functionalities it has. Basically, this provides real-time operation and gives the view of what the objectives and which is the predictions and the prescriptions can do for the asset.
Great, thanks, Vicky.
I will stop sharing.
Okay, so you guys saw the demo, and now we wanted to walk you through a couple of those examples. So how did we actually go about configuring this? What does it look like? How do you set the different objectives and what actually is being prescribed? So Roberto, I'll hand it over to you.
Yes. So here we have our Pyro process Optimum product and the way that is configured. So basically, we look at your specific asset, kiln, and cooler, and then we detect which of these inputs are needed, which are your goals and constraints, and then we configure those against your specific need. If you look at the Pyro process, we have basically working together to pipelines that allow you to do estimate the dynamics of the system, the optimization. And you can start with a standalone cooler if you want. That is a possibility. Or we can start a project with a complete Pyro process. So typically in the cooler, you want to maximize heat recovery and have stability. And that in turn will help your kiln to have better inputs, let's say more stable secondary, tertiary, and be able to reduce the amount of fuel and saving energy in the kiln. And also at the same time, we can look at your different requirements. Either if you want to, let's say, optimize the use of, let's say, alternate fuel. If your objective is to have more stability, each kiln is different. We know that it has the complexity can be high and it can be different, but the AI Optimum product can be configured to any of them to either increase the yield. Is that if you are in a market that requires more product, have more stability, or let's say you're in a market that you are producing, you're not at 100%, but you still want to have the optimum, let's say, kilocal per ton, or the optimum optimization of energy consumption. Optimum can be of great value for optimization.
Great. And I'm going to go ahead and launch our second poll, which is, if you were going to launch Petuum Optimum for asset optimization, which one of these assets do you think that you would probably start with? Would it be the cooler only? Would it be the Pyro process, ball mill, or vertical mill? Alrighty, I see some answers coming in. Right now, we've got a leader, but I'll give it a few more seconds. Okay, so for this poll, the leader was the Pyro process. So it looks like we picked the right one to give an example configuration for.
Excellent, excellent. That's very good.
Alrighty.
Yes, and this is some data for some of the implementations, and we are seeing that, for example, in the cooler side, we have seen increases of temperature consistently. These are two different sites. You see an increase of secondary temperature, tertiary air temperature. And this graph, if you see below, is really interesting, and it gives a lot of information about the power of AI. Any of the coolers that use a standard methodology of control use a table, right? And that table is kind of optimized for one single range. So it means that when we are in that range of, let's say we are in the 250, let's say, tons per hour for that kiln, in that feed, we're not going to be doing much better. However, as we move across the different capacities, higher capacities, much higher capacity, or even medium and low, we have the optimum doing much better at every time. So this means that you don't need to recalibrate, your table, right? So you are effectively using a dynamic table that is created by AI adapting all the time, and that can always be retrained and retuned. So that, I think that's the most powerful message. And this, of course, it's is the reason is the AI brings more dimensionality and capture more corner cases than a linear system can do. Mm-hmm. Yes, and here we're working with our subject matter experts in the company, and we are helping customers to estimate some process savings based on the improvements that we have seen in certain variables in the system. For example, for the Pyro process, we see that the increase in throughput can be very beneficial, especially if you are in a market that is completely sold out. If you are in the area of saving energy, we know what is the savings that we can obtain, and we can do this exercise with you in a one-to-one basis. Here we have assumed some medium size or typical capacity of a kiln, typical specific energy consumption, and some some typical values for the electrical or and fuel consumption, all of those costs associated in a basically like an average case. But we can also work with you to estimate that, to have an idea of what will be the benefit of Optimum. Then once you have been, if you have interest, we can also start with an assessment. But then for that, we have a pathfinder approach where we get your data and we can do an assessment and see, and with historical data, how well we can do prior to put this in, let's say, in a supervised or supervisory mode. Mm-hmm.
Exactly. Thanks, Roberto. And as he mentioned, in case you guys didn't catch that, if you wanted to run these calculations, get an estimated ROI for some of the savings on your assets, because clearly this was based on one that we have certain assumptions over here. We're happy to do that exercise with you as well. So feel free to contact us afterwards, and we can get you the details there. So that wrapped up the application for asset and process optimization. I wanted to spend just a quick minute talking about how we are using computer vision for this as well. And then we're going to open it up to some questions and answers. So this application here is how are we able to use computer vision for visual inspection. And so that can be from a number of different data sources as well, whether it be photos, videos, infrared, EOIR, excuse me. So what you're seeing over on the left is an example use case that we've done. And so this was actually within the metal space. So apologies, I couldn't get an example for cement today, but what you're seeing here is some sample images. Here on the zoomed in, you can see the red, which has, we've used that CV functionality to identify the defects or the anomalies. And basically we're going through, we are loading in different data sets, classifying what the defect would be, and then being able to help accelerate the turnaround time in order to tell your operator, tell your SME, your quality assurance personnel, what that potential defect would be. And so here, this table is showing 2 different training sessions that we did with 18 and then 32 different classifications of defects. And so here you can also see the timeline and then the determined accuracy. And so clearly these would be adjusted depending on the amount of data that we have for each one of those defects, making sure that the sample data set has an array to cover. So if we are going to be looking at let's transition over to cement. So the first application here potentially could be looking for defects or abnormal applications. And so maybe you're looking at the size of the clinker in the feed rate and trying to understand how is that going to influence the final product quality, or even the way that you actually manage your production process. Is there a way that we can tie in the visual now in addition to the time series data to further optimize on what was already done with Petuum Optimum? So some of the applications could be the defect detection and identifying abnormalities. Also the quality prediction. So not only being able to detect the defects after the fact, but are we able to tie this back into the root cause of what's actually causing the clinker to be larger? Or Roberto, chime in if you have any other suggestions. Yeah. But
yeah, for example, we can look at the camera as the same way that the operator sees it and abstract information directly from the burning some camera where you will see the flame. An operator is making decisions, and looking at that, we can use that data as well. Customers have shown interest into detecting prior to the formation of a hotspot in the shell. We can look at the data and find a hotspot formation. I mean, and there are many other things, like you mentioned already, particle size distributions. Let's say dusty clinker versus the regular clinker, and then you know, we know that in coolers there are cameras that where you can see that there are, let's say, this red river. So detecting that, looking at that, and sending an alarm, those type of applications are totally possible with image detection.
Great. So I have our last polling question for you folks. So now you have seen 3 different applications within the cement manufacturing process. So just as a reminder, we had the soft sensors, the asset and process optimization, and now the visual inspection. I have this poll asking you guys, of these applications, which one do you think would provide value to your organization? And I think this is a multiple choice, so if multiple apply, feel free to select a couple. All right, we've got a couple answers coming in here. Alrighty, thanks everyone. So it looks like the winner was, oh, one more, asset and process optimization by a long shot, but and then we have a tie actually for soft sensors and visual inspection. So I'm betting that a couple selected multiple options. Great. So just to bring us up to a close here, to summarize, so you saw a couple of the applications today just for the manufacturing process. We as Petuum, we're trying to solve a couple of these larger problems with how do you actually implement AI at your organization in a cost-effective and a scalable manner. And so whether that be being able to bring your ideas to production, having end-to-end services that provide you a return on your investment, whether that be the actual AI at scale. So how do you bring this from line to line, application, use case to use case, or how do you help augment some of the in-house talent that you have who are actually building these models? And so that's all I have for you folks today. We can open it up for question and answers. And just as a reminder as well, everyone who's on the line today will be receiving Roberto's peer-reviewed paper on AI for clinker coolers that would have been at the IEEE conference. And if you guys, again, like you want to see the ROI calculator on your assets, feel free to give us a shout at business@petuum.com.